first thing, if you have the graph paper, just draw your triangle. So plot it out. -3, -1. 1, -3. This is down here. 3, 1. We got a little triangle that looks like that.
It is.
Okay? Let's work on this first. So first thing we want to do to classify is there's 3 classifications. Right? There's scalene. So that means no side lengths are equal. There's isosceles. Two sides are equal. And third, there's equilateral. That means all sides equal. Okay? So obviously we're going to be doing something with side lengths here. So we're just applying the length formula 3 times. Because is calculate 2 side lengths enough? No, right? Even though they're the same, even though they're different, if they're the same, they still could be equilateral. If they're different, it still could be either scalene or isosceles. So you need to calculate all 3 lengths. So length of AB, will be the square root of -3. So formula is x minus 1 squared plus -1 minus the -3 squared. So that gives me -4 squared plus 2 squared. So that gives me 16 plus 4, which is square root of 20. If I reduce that radical or simplify that radical, that's 2 root 5.
Oh, does it minus -3?
Yes. Okay, so length of BC so 1 minus 3 squared plus -3 minus 1 squared. So that gives me -2 squared plus -4 squared. I can see that this is already going to be 4 plus 16 is equal to root 20, which is the same as 2 root 5. So we already see that we're on the path to being an isosceles triangle. Okay? We need to take care, and I purposely put in this question coordinates with lots of negatives in there. I messed up. You see my student teaching when I taught this unit, it was brutal. I was making mistakes left, right, and center. Okay? Need to practice getting the arithmetic right, being careful with their signs, making sure we're getting our answers correct. Okay, so I did label it, so this was A, B, C. So basically we saw that these 2 sides are the same. And I would do the length of AC. I get the same thing. Well, I won't get the same, I do the same thing. So square root of -3 squared plus -1 minus 1 squared. So that's equal to -6 squared plus -2 squared. And that's equal to square root of 36 plus 4, which is root 40. Okay, so we tell right now this is scalene, this is an isosceles triangle. Okay, another thing that we can do that we're going to be looking for is this a right angle triangle or not? Now that we're dealing with slopes, so right angle triangle implies what? What angle do we have in there? 90 degrees. So there's a couple of things that we could do. Jordan pointed out that we could take our side lengths and do a squared plus b squared equals c squared. So this one you sort of have to play around a little bit. You can kind of see that this is the longer side. And if we apply that formula, it might work. I like to use the slopes. Okay, so another way you can do is use the slopes. And if you draw the picture, you kind of see that this is not, and this is not. It looks a little bit too small. This is the one that has the potential. So if I calculate the slope of AB, I lost my points. So delta y over delta x. So here, a minus b, so I get minus 3 minus the negative 1. And then 1 minus the negative 3. So here I get negative 3 plus 1 over 1 plus 3. That gives me a slope of negative 2 over 4 or negative 1 half. And if I calculate the slope of BC, so same formula again, delta y over delta x. So 1 minus 3 over 3 minus 1, and I get negative 2 over 2. Is that right? No. 1 minus, I forgot the negative sign. 1 minus the negative 3. So that should give me 4. Over 2, which gives me 2. So there are my two slopes. Are they negative reciprocals to one another? Right? So since slope of MAB is perpendicular to slope BC, it is a right angle triangle. Okay? So these are some of the things I want to start seeing when it says, you know what, classify a triangle, what kind of a triangle do we have? And these are all the calculations that we need to do. So let's do a Pythagorean theorem, right? A squared plus b squared is equal to c squared. So what's my a? It's really square root of 20. Plus my b would be square root of 20 squared. And what's my c? Square root of, this is a 40. 36 plus 4 is square root of 40. If I square everything, well, square root of 20 squared is just 20 plus 20 is equal to 40. So 40 is equal to 40. So there's my check here. And that's another way you can say that, well, since the Pythagorean theorem works, there must be a right angle. And then you can actually identify, well, it's the one opposite my longest side. So this was my longest side, so it must be that angle here. That's the right angle. Okay? So that's another thing that we start doing is verifying shapes with analytical geometry, with stuff that we're doing. Length of a line, slopes, midpoints, perpendicular bisectors, all that stuff will be used to verify shapes. There's one key point I want to make in today's lesson. And this goes back to, I think it was the last question in the Smarties package that I gave you guys. So after today's lesson, I hope you go back and do that question. Actually, I think I'm going to do it here as an example. So here, the shortest distance from a point to a line. So in other words, we want the shortest distance from this red point to this line, to this blue line. We can calculate that. We can actually find out what our shortest distance is. And that distance is the line segment that is perpendicular to the line from that point. In other words, if we draw a perpendicular line that goes through this point and is perpendicular to the blue line, so this is perpendicular, this is the shortest distance right here. Let's assume that that's not the longest side. That's not the shortest way. Okay? Let's say it's not. So let's say that this over here, some other point on the line, is the shortest distance. Okay? So we'll draw a point from that to a shortest distance. What do we get? We get a right angle triangle, right? This is also 90 degrees. But which side is the longest side of a right angle triangle? So which one's the hypotenuse?
The opposite of the straight angle.
This is the hypotenuse, right? But we just said that this has to be shorter than that.
We lied.
Contradiction, right? So therefore, this has to be the shortest side.
So we make the shortest side a lot bigger.
Yeah, so we prove by contradiction, right? In other words, we say that this is the shortest line, but as soon as we make a right angle triangle with it and we have a 90 degree, we contradicted ourselves, right? So that's actually one way mathematical proof that you can actually prove something. Assume one thing, but if it turn out that something else is false, then your assumption is actually false. So in theory, this has to be the shorter side. Okay? So that's sort of the logic tied into it. Let's have an example for that. I think this was the example that was on your sheet. Okay? So here we have a point, A, 6, 5. And there's our line. So this one is 2x minus y plus 3. So how can we calculate the shortest distance? So you can almost treat this as, let's say this was a road, right? And I have a cottage right here. But I have no road to meet this main road. I want to build one. So I want to build the shortest road because that would be the cheapest for me, assuming that I could bulldoze anything in that Cartesian plane. So this is how I can calculate, well, what is that shortest distance so I can know how much I can spend per foot, per meter on building that road, and how much that road will cost me. So that's more of like a practical example of this. So you can treat this as a road, but we want a shortest distance from this point to this line. So how can we calculate that? What is that distance? What are some of the things that we need? Okay, so we need the slope of the line. And why do we need the slope of the line? What does that give us? Yeah, so this will give us the slope of the line perpendicular to it, right? Because we want a line that's going to be perpendicular to this. So if this is the shortest path, we want that to be perpendicular, right? So if we find out the slope of the blue line, we can get the slope of the green line because they're negative reciprocals, perpendicular. What else will we need?
The length.
Well, we're going to calculate the length, but what things do we need before we could even try to calculate the length? Midpoint of what? There's no midpoint because it's just an ongoing road. You're not giving any endpoints.
It's an ongoing.
Well, we have the coordinates of A.
Coordinates of C.
The equation was on.
Oh, the equation.
Which equation?
The equation from vertex A.
Well, we need the equation of this green line, right? In other words, we need this equation of the shortest distance. So we need the equation of the line of the shortest distance. So we need an equation for that green line. Because getting that equation for the green line, we should get our third thing. What's the actual third thing that we need?
The length of the.
No, we're going to calculate the length. Sorry? Yeah, we need this other point. We'll work backwards. What we really need is we need that point. We need to identify where on this road or where on this line are we actually going to get to it, right? Because we need to calculate this distance. So we'll call this B, let's say. We need to calculate distance from A to B. So we need point B. Or, what is that? The point of intersection. I know, that goes way back to like September,
Middle school.
where we did solving equations. It's funny how things come full circle, pun intended.
Oh, circle, get that.
Nah.
It's because circles are round. Right? And everything goes back.
Okay? So in order to solve this problem, I want to see that this is what we need to do to break it down. Each of these steps is a piece of work in itself. Right? And then finally, once we have our 2 points, we just apply our length formula. So, how can we calculate the slope?
Negative.
Well, how do we get the slope of our equation of a line?
We have a.
A.
Fine.
Put it in y
We need-
x plus b.
We need the slope of this line. That's what Alex said, right? We need the slope of that line so we get the slope perpendicular to it. So how do we get a slope of that line?
Just look at the lines. Goes up by 2.
Yeah, I mean, we have the equation of the line, right? The equation of the line is 2x minus y plus 3. So what form of a line will give us the slope?
Y equals
Y
mx plus b.
equals.
Yeah, so we just need to convert that to y equals mx plus b. One isolate for y. So we want to convert, as Amy said, convert it from standard form to slope-intercept form. I want to isolate for y. So how can I isolate for y in this case? Elena, can you see? Elizabeth?
Bring over. Oh, which one first? The 3.
Bring over, well, so we don't bring over things.
Oh, you
We
bring
want to
over.
add and subtract things, right? Or multiply, divide things.
Oh, okay, yeah.
So you want to subtract 3?
Yes.
What you do will get us there. Let me show you a little bit faster way. Can I add y to both sides?
You can.
You see that?
Yeah.
So if I add y to both sides, I get 2x minus or plus 3 is equal to y. I set it for y in one step.
Do I have to just do that extra step?
What extra step?
Second one. Like the plus one.
The same gets it.
I just added y to both sides.
Can you just go like,
Just go straight to
yeah,
2x plus
2x plus 3 goes by?
Yes, I just want to demonstrate for those who might not be seeing where we get that from. Okay, so instead of subtracting 3 and then subtracting 2x, and then multiply both sides by -1, this is a little bit faster to get there. So your way would have gotten there as well. So what's the slope here?
y equals 2x plus y.
What is the slope?
2.
Right? So the slope is 2. So what's the slope perpendicular to it?
Negative 2.
Negative 1 over 2.
Yeah, -1 over 2. Yeah. So now that because we want the equation of that green line, so we're going to start off with y is equal to mx plus b. But we just figured out the slope. Do this. So y is equal to -1/2 x plus b. So going back to last class, how do we actually solve for b?
Yeah, plug in the coordinates.
What coordinates?
I don't know which coordinates now.
Well, here we're only given one coordinates, but is it on the green line? Right.
Yeah.
It has to be a point that's on the line. So it does have to be on that line. It makes sense because we're looking for an equation that goes through that point.
Was it on the quiz as well?
I don't know. I forgot the quiz already. Yes, it was. Okay. So you see that we're just kind of like doing the same things on that quiz over and over again, but we're just having different circumstances to apply it to. You have a question? Yeah, sorry. So when x is, What's our coordinate? 6, comma 5. So when x is 6, y is 5. Right? So we got 5 is equal to negative 3 plus b. So that gives us b is equal to 8. So therefore the equation is y is equal to negative 1/2 x plus 8. So now we've done 2. How do we get the point of intersection?
You do
The third step.
2x plus 3 equals negative 1 over 2 plus 8, and solve for x.
So what method did you just use?
She used
I
the
don't know.
she equals, they equal each other.
Substitution.
Yeah, right? We saw y is equal to this.
Wow.
So we saw that y was equal to this, right? And so in this other equation, we substituted y for that. Alright? What was the other way we could do this?
There's the substitution.
What was the other method? Elimination. So I'm going to do
Oh
elimination.
no. There's more than one method.
Yeah, because we learned that.
Oh, I remember. It's coming back to me.
So I'm going to do elimination. So here I got y is equal to 2x plus 3 minus y is equal to minus 1/2 x plus 8. So when I subtract those, the reason I chose it because I have y's by themselves. So I know y minus y is going to give me 0. 2x minus 1/2 x. So it's really 2 plus 1/2 x gives me 5/2 x. And then 3 minus 8 gives me
Negative 5.
negative 5. So now I'm solving for that. So I'm going to add 5 to both sides. So I got 5 is equal to 5 over 2x. Then I'm going to multiply by the reciprocal, 2/5. Over 2x. The reason I multiply reciprocal because double eliminate that just gives me x. And so here I see that x is equal to 2. So that's my x coordinate. Pardon?
Oh, 2 of x, subtract
How do you get 5 over 2?
that's the longer
Substitution?
Yeah.
It works something
No,
else.
Oh, I see.
I believe I tried it last night. It was the same thing. Because in the end, what were you doing? You were subtracting 2, or you were adding 2 plus 1/2 x, and you're doing.
Substitution is easier.
It is. I see it better. I'll say that. I see substitution better. Process is pretty much the same. So for x, sorry, yeah?
What do you do after 5? You do 5 over 2x.
So because I have 5 over 2x, if I multiply them by the reciprocal of my coefficient, right? So I take the reciprocal of that, if I multiply it, all that counts as I get 1. But if I multiply by 2/5 on this side, I multiply 2/5 on the other side. So 2/5 times 5, the 5's cancel, just leaves me 2. Okay? So now I got x is equal to 2, how do I get y?
You put 2 in either.
Yeah. And I'm going to choose the second one because there's no fractions. So here the equation was 2x plus 3 is equal to y. So that's 4 plus 3 is equal to y. So y is 7. So therefore the POI is 2 comma 7. Okay. You guys writing this down as we're going along? All this work that I'm doing?
Just drawing infinity signs.
Okay.
I will.
Where are we going to get this down though?
Get it out right now.
Just want to pay attention first, understand.
You want to go over the substitution part? Yeah.
You want me to do the substitution way?
Right?
You want me to do substitution by substitution?
Yes.
If I do it by substitution, so I get 2x plus 3 is equal to minus 1/2 x plus 8. I want to add 1/2 x to both sides. I get 8 on that side now. Now I subtract 3 from both sides. Right? So what's 2x plus a half x? What's 2 plus a half?
5 over 2.
Yeah, 2.5 or 5 over 2x. And what's 8 minus 3? You see that we actually came with the same math almost? 8 minus 3 is 5. Now we'll multiply this side by 2/5. So we're going to multiply that side by 2/5. The reason I multiply by 2/5 is so that those cancel out. I'm just left with x. And here I get x equals 2 as well. Okay. So now that we have a point of intersection, we got the 3 things that we finally needed. But we're not done because we haven't answered the question yet. But this one is going to be hopefully the easiest one of all. But do you see how much work it took just to make sure we got this point? That's all we were looking for, that 1 point. So that we can do L is equal to square root of x2. So I'm going to do 2 minus, was the original question 6? Squared plus 7 minus 5 squared. All that work just to get to there. So L is equal to square root of -4 squared plus 2 squared. That's equal to square root of 16 plus, how come we keep coming with square root of 20? So L is equal to square root of 20. We reduce that radical, it's 2 root 5. And that is the length. So that is the shortest length from that point to that line.
And a question like this would be 6 weeks.
It'll be worth quite a bit, right? But do you see that this test is going to be a struggle in terms of we need to understand a process because we don't have a lot of time to think.
When is this test?
This test is
It's on
on May
Blackboard.
10th.
Oh my god, we have so much
Well, it's on the,
the next couple
for
weeks.
you guys, it's on the Friday. Are you going to study and be ready for it by the Thursday? No. Right? This is what this whole couple of weeks is for. Practicing, getting ready for this.
Yeah, but this would be like the last question on this.
No.
No. Oh no.
That might be. This is a difficult question.
Like this is the end of the
This-
year. Now it's just conclusion.
I mean, when you think about there's these types of questions, you can calculate this. I could ask you to calculate the center of a circle, which again is sort of the same thing. You need to do two equations, solve for 2 equations, and then actually that was a little bit easier because all you need is a point of intersection. You don't have to do anything with it afterwards, right? So in reality, this might be the most challenging type of question.
So the last question.